Alright, the first one is problem 22. It's a quadratic equation, and the instructions say solve it by completing the square. So to complete the square, we have to get that over there. So we subtract 1 from both sides, but we leave a space where the 1 was. Now we say the square that will give you x minus 5x will be x minus 5 over 2. But to complete the square, we have to square that. Squaring that, we get 25 over 4. But whenever we add to one side, we add the other side. Now changing that becomes negative 4 over 4 plus 25 over 4. So that's x minus 5 halves squared is 21 over 4. So to eliminate the square, we take the square root of both sides and put positive and negative over there. The square root of anything squared is what's inside. This becomes positive negative square root of 21, but we have the square root of 4, and that's 2. We add 5 halves, and there's our answer. Solving by completing the square. Problem 32 was to be done by the quadratic formula. Quadratic formula says x is negative b plus or minus square root of b squared minus 4ac over 2x. So what are these a, b, and c? Well, a is the number in front of the x squared. So a is 10. B, the number in front of x, is 9. And c, the number by itself, is negative 7. So the solution, negative b is negative 9 plus or minus square root of b squared, which is 81, minus 4 times 10 times negative 7 over 2a is 20. Now that minus and that minus makes plus. 4 times 7 is 28 times 10 is 280. But that's 361. And the square root of 361 is 19. So you have negative 9 plus 19, which is 10 over 20, which is a half, and negative 9 minus 19, negative 28 over 20, which is negative 7 half. Solving by the quadratic formula. 39 is pretty easy, but most of you got it right. You multiply by the complex conjugate of the denominator. That's 1 plus 2i, and whatever you do on the bottom, you do on the top. Wrap them in parentheses and FOIL them. The denominator, the middle, the inner is negative 2i, the outer is positive 2i, so the middle term drops out, and you just have 1 minus 4i squared. In the numerator, 2 times 1 is 2, negative 3i and positive 4i is plus 1i, and minus takes I squared. But remember, I squared is negative 1. So this becomes 1 plus 4, and this becomes 2 plus 6 plus I. Well, that's 8 plus I over 5. That's good, or you can write it as 8 fifths plus 1/5 I. Alright, here's another quadratic formula problem. A is 2, B is negative 2, C is 1. So x is negative b, which makes it positive 2. Sum of b squared, which is 4, minus 4 times 2 times 1 over 2a squared. So that's 2 plus or minus sum of 4 minus 8 over 4. If 4 minus 8 is negative 4. And when you have a negative, that becomes negative 1, the square root of negative 1 is I. The square root of 4 is now 2, so it's 2 plus or minus 2i over 4. But you can put both terms over 4, so that's 2 over 4 plus or minus 2 over 4i, which ends up being 1/2 plus or minus 1/2 I. I think we have 2 more problems. We have 3 more. Here's a challenging problem. It's an equation that has fractions. The common denominator is x times x minus 3. There are 1, 2, 3, 4 terms. All 4 terms get multiplied by x times x minus 3. In the first case, the x's cancel. And so you get 10 times x minus 3. In the second one, the x minus 3 cancel, and you get negative 12x. In the third term, nothing cancels, so you get 4 times x minus 3. And on the right side, you have 0 times anything, still 0. Distributing, we get 10x minus 30 minus 12x plus 4x squared minus 12x equals 0. Combining and rearranging, we have 4x squared, and a 10x, a negative 12, and a negative 12. Well, that's negative 24 plus 10 is negative 14x minus 30 equals 0. And factor it 2 out. And we can see we can factor that. We can have 2x and x. And we put 5 and 3. We put 5 and 3 in it. 3 and 5. We put a minus and a plus. So that would be 2x squared plus 3 and minus 10 is negative 7. Minus 15 is 0. Since the factor is equal to 0, 2 equals 0 is nonsense. Saying 2x plus 3 equals 0, we get x is negative 3 halves. And saying x minus 5 equals 0, we get x is 5. Over here we have a radical. If you have a radical, you're going to isolate the radical. So subtract 1. Then you have a radical, you square it. But whatever you do to one side, you have to do the other. When you square a radical, you get what's inside. When you square a binomial, you get that squared. You get the middle term doubled, and you square the rest. Well, now we have a quadratic. We want to subtract 2x and subtract 1. That gives us 0, and x squared minus 4x. We can factor out an x. We set the factors equal to 0. So we have two answers, 0 and 4. But in the case of radicals, we have to plug them in and see if they make anything, if they work. To put 0 in, we would have the square root of 1 plus 1 equals 0. That's no good. So we throw that out. We put 4 in. 2 times 4 is 8 plus 1 is 9. 9 plus 1 is 4. But 9 is 3. So 4 works. So we solve for two answers, and only one of them fits the initial problem. Last math. Have a 4-point graph. 0, 0, 0, negative b over 2. If x is 0, y is 4. If y is 0, we have to set that equal to 0. And we just solve that by the quadratic formula. Negative b is negative 6. B squared is 36 minus 4 times negative 1 times 4 over 2a, which is negative 2. So that's 36 the square root of 52 is not a perfect square. Let's say it's about 7.2. So negative 6 plus 7.2 is 1.2 over negative 2. That's negative 0.6. Negative 7.2 means negative 13 over negative 2, which is positive 6.5. Finally, negative b over 2a is negative 6 over negative 2, that's 3. We put 3 in, we get negative 9 plus 18 plus 4. 22 minus 9 is 13. So we have our point. 4, negative 0.60, positive 6.50, and 3.13. Just like that. The vertex is there. These are the intercepts, and the axis of symmetry is x equals 3. Alright, that's good.